Hi, my name is Solomon, and today I will walk you through how to remove an arm from one of our LoCoBot platforms so that you can use both the LoCoBot and the arm independently from each other. It will cover both the hardware setup as well as the software setup. For the hardware setup, you will need a 2.5mm Allen key wrench, a 12-volt, at least 2-amp power supply, micro USB cable, a XL/XM motor power hub, a U2D2, and a 3-pin cable. This 3-pin cable will be used to connect the motor power hub and the U2D2 together. You will also need some way of keeping the arm from toppling because it'll be a standalone arm. In our case, we're using a 5-pound scuba diving weight, but you could use any heavy object lying around like a textbook. For this specific demo, we are using the LoCoBot Widow X200 product, like you can see here. And we are taking off this arm from the rest of the LoCoBot, essentially turning the LoCoBot into our LoCoBot Base version. So let's get started. First, unplug all cables from the battery. Next, unplug the 3-pin cable going from the hub to the waist motor. Remove the 6 screws bolting the arm plate to the Kabuki base using a 2.5mm hex drive. Slide out the arm plate. Note that the battery will come out with it as well. After placing the arm plate in your desired spot, remove the battery and place it back on the Kabuki base. To secure the battery, you can partially screw in 2 of the original 6 screws used to bolt the arm plate as shown here. Then plug in all the cables. Make sure to connect the 12-volt supply to the motor power hub, the 20-volt supply to the computer, and the 5-volt 2.1 amp USB power supply to the LiDAR if equipped. Finally, place a weight on the plate to make sure the arm is sturdy. Plug the U2D2 power hub and arm together. Now that you have successfully removed the arm from the LoCoBot platform, let's talk about software setup. For this tutorial, I'm assuming you're using your personal laptop and that it runs Ubuntu, Linux, and ROS. If you haven't yet installed any ROS packages for our products, then you can head over to our tutorial on getting started with our ROS arms. The link is in the description. If you already have installed ROS packages for some of our products, this tutorial will walk you through how to get the ARM-related ROS packages to control your standalone ARM. So in our case, I'm using Ubuntu 18.04 and ROS Melodic. I'm going to open up a terminal by pressing Ctrl-Alt-T. Then I'm going to go into the Interbotix workspace source directory that I already have. Type L to see what the packages are that I currently have. So I already have Interbotix ROS Core, Interbotix ROS Toolboxes, and in this case, I also have the Interbotix ROS Rovers repository as well. So this laptop could theoretically be used to work with our LoCoBot platforms. But to work with our standalone ARM, we need another repository called Interbotix ROS Manipulators. So let's head over to the repository here, github.com/interbotix/Interbotix ROS Manipulators. Go here and just copy the link for the repository. Then in our terminal, we're going to type git clone and then paste that text, then press enter. Just take a few seconds to get all the packages. So if we press L again, we'll see that it is now in our directory. Before building, we're going to need to remove some cat can ignore files. The cat can ignore files, by definition, make it so that if you compile your code, it will ignore any packages in the same directory as the cat can ignore file. So if we go to the Interbotix ROS manipulators repository and press L to see the contents, we'll see there's two different types of folders. One is Interbotix ROS UX arms and one is Interbotix ROS XS arms. The UX arms directory is, it holds the ROS packages for controlling the universal, the X arm by universal factory, whereas the Interbotix ROS XS arms ROS packages hold the code to work with any of our built in-house X series arms. So in both of these directories, you'll actually find a cat can ignore file. But since we are using an X series arm, we're going to remove the cat can ignore file in the XS arms directory. So if you press L, you can see the cat can ignore file right there. So let's remove it by typing rm space capital C, then you can press tab and you'll have cat can ignore pop up. Just press enter. So we remove that. If you type L again, you'll see that it's no longer there. If you do plan on working with perception, so if you're working with the standalone arm, for example, to use our custom Interbotix XS arm perception package right here, you're also going to want to remove the cat can ignore file in that directory. So change directory, Interbotix XS arm perception. And if you look in there, you'll see another cat can ignore file there. And the reason I have that there is because there's a lot of other code dependency software that you'll need if you wanted to use the Interbotix XSR perception ROS package. So if you're confined to a small space for your project, then there's no need to install all that extra code if you're not going to use it. So let's just remove that one, because for the sake of this tutorial, let's just say that I do want to use this package. So we're going to type rm space capital C, capital A, tab, then press enter. And we can see that the cat can ignore file is no longer there. Then head over to the root of the workspace, and we are going to use this handy command here. Raw step install from paths, source, ignore source, -r-y. So that command is a command that allows you, that it searches through your whole entire workspace here, and it will it'll install any dependency packages that are missing for all of your ROS packages. So we're just gonna hit enter. So here we're getting a message that says that all required ROS steps installed successfully, so we're good to go. I'll just make a note. Yeah, we do have an error here saying that a certain ROS package called Rokon apps is not available. That's something specifically for a ROS package called Kabuki capabilities, which is focused on just doing something with the Kabuki mobile platform. It has nothing to do with our working with our ARM ROS packages, so we can just ignore it. Now we can type cat can make in the root of our workspace like that, then hit enter. This will build all of our ROS packages. It'll take a few moments, up to a minute or so. All right, now that everything is built, let's just test it to make sure that it's working correctly. So we're going to do ROS launch Interbotix XS arm control, XS arm control.launch. Robot model is equal to mobile WX200. Since our original LoCoBot contained the mobile Widow X200 arm, so when we take it off, the arm standalone by itself is the model name is just mobile _ Widow X200. We're going to press enter. Okay, we're getting a message here. It's saying unable to contact ROS master at locobot.i.local. Okay, so that's just a mistake on me. ROS is trying to contact a different robot for its ROS master, so we can just change that very quickly by going to our -rc file. We're going to comment out this command here. Then we're just going to save it by pressing Control O, Enter, Control X. We're going to exit the terminal and just open up a new one and type that command again. ROS launch Interbotix XSARM control XSARM control dot launch robot model is equal to mobile WX200. Press enter. And looks like our robot is appearing correctly. All the motors have been found. So you're good to go to develop on your standalone arm. That's it for this tutorial. See you in the next one.